Okay, I just came back from lunch. I'm feeling really good, so I'm about ready to start another section here of supply and demand and equilibrium. Again, we said that supply and demand is the economist's most favorite tool in their little bag of tricks when we ask them a question. They'll come back to this analysis, so we're going to do some easy ones, and then we're just going to up the ante and make it a little bit more difficult. So this D stands for demand, stands for S. When I draw the up arrow, I said, okay, we're going to increase demand, but we're going to leave supply alone. And what will our graph tell us when we increase demand and leave supply alone? Well, an increase means that we've got to move the demand curve to the right. I'm going to use my red marker here. Well, wait a minute. I got to do something first. When you see a test question like this that says, okay, what's going to happen if you increase demand and supply stays the same? The first thing you do is you take some white paper on your test and you draw this axis. You put the P here, you draw this axis Q, you draw the demand curve, draw the supply curve, put the D and put the S. And says, okay, now and only now I'm ready to read the question. So we put a 1 right here, and we're saying there is a price at that equilibrium, P1, and there is a quantity at that equilibrium, Q1. Now I'm ready to read the question about, okay, we're going to change something here. We're going to leave supply alone, and we're going to increase demand. Now we're ready to do that. So now we're going to increase demand over here to D2. Now remember, we can only have a demand curve at one place at a time, and so in our mind's eye, this D is now gone because it moved to the right. It increased, so I'm even going to erase it. I'll leave this little thing here, but I'm going to erase it because we have a new equilibrium point. When demand increased, this demand curve moved up, the intersection moved up to the supply curve, up to the intersection. We're going to call that point 2. Now, point 2 equilibrium has a price associated that is higher, and it has a quantity, Q2, that is higher. So now we're going to say price and quantity. When we do these changes with supply and demand, price could either go up, it could go down, it could stay the same, or we could say, heck, we don't know, with not enough information to know. Same thing with quantity. It could go up, it could go down, it could stay the same, or we could be in a situation where not enough information, we can't say. So in this case, if supply stays the same, demand goes up. In this case, the price goes from point 1 to point 2. That is an increase right here, an increase in price. And from Q1 to Q2, that's an increase in quantity. So there's where our two X's would go. In this case, we would have an increase in price and an increase in quantity. So good so far? Good. We're going to try it again. What do we do first? Demand curve, supply curve, call that point 1. We have a P1. We have a Q1 that's moved on me here. Q1. And let's change what's going on here. Let's say that demand goes down a little and supply goes up a lot. What's going to happen to the equilibrium price and the equilibrium quantity? Now let me pause here. Don't guess. Why guess when you can know? Don't guess when you can. You've got this nice handy graph here, and just let the graph tell you the right answer so you know for sure. All we have to do is say, okay, I'm going to decrease demand a little bit. That means I'm going to bring it back a little bit. Let me get rid of this thing here. Too many lines in here. So demand's going to come back here just a little bit. Call that D1. Now notice what we did. We reduced demand, moved it back this way just a little bit. Now that took us from here down to here on the supply curve. What else is happening? Oh, supply is going to increase a lot. Supply is just going to really increased. So let's move supply way out here. I'm going to use red for our change in supply. I'm going to move it a long way. Now we only move this back a little way, but we're going to increase supply a lot. So it's going to be clear over here. S2. Now, we were here at this point here, but when supply increased, it took us down to this point right here. We're going to call that P2. All right? So now we can get a P2, point 2, price 2, and a quantity 2. So if demand goes down a little and supply goes up a lot, what's going to happen is that the price is going to fall like a stone, and the quantity is going to go up by some measure. So what happens in this case, price goes down and quantity goes up. So far so good? Now once you're getting the hang of this, we can just make it just a little bit more complicated here, but this is the basic idea. You start off with the initial demand and supply, and that's point 1. So you get a P1 and a Q1. Then you move both curves, whichever way we have to move them. Now in a word problem, you would say, how would this go? Let's say we've got I'm trying to think of an example on the fly here. We're going to radically increase the demand, the supply of bananas, because now we have diplomatic relations with Cuba, and Cuba's market has opened up and they got a lot of bananas. So all of a sudden the supply of bananas comes up because now we've got diplomatic relationship with Cuba. Now we can do business with Cuba, which we haven't been doing for many years. But at the same time that we have diplomatic relations with Cuba, which opens up the supply of bringing bananas in from Cuba, people are reading about bananas, and they're not just as hyped up, and they're all calories, and they tend to make people fat, and they're like candy food. They don't have any nutrition, and they're just candy, so people think, I don't think I want as many bananas, and so the demand goes down slightly, but the supply goes up. What can we expect to happen to price? The price will come down, and people will buy slightly more bananas than they did before. That would be an illustration of a word problem using this analysis here. Let's do another one. Hang on with me. We're going to crash through these. And remember, if you can follow me here on your computer monitor, and if this makes sense, and if you can do it here in these tutorials, then you can do it on a test. And that's the whole point here. Let's put P for price, Q for quantity. The first thing we do before we even look at the question is we say, well, before I even look at the question, whatever it is, I know there's a demand curve for it. And whether we're talking about bananas or Mercedes-Benz, I know there's also a supply curve for it. Now, I didn't do that demand curve very well. I told you that they all tend to slope down a little bit, and then I didn't do it right. They all tend to droop a little bit like that. And so now we're going to have an equilibrium price. We'll call it point 1. With a P1 and a Q1. Okay, now what's the question for this one? Let's make up a question. What's a question here? Let's say that demand goes up a lot and supply goes up by the very same amount. They both increase. Now in this case, I want you to see this supply curve is like, think of a long dowel here. If I had a long dowel here like this, and as I increase supply, I'm going to move it this way. I'm going to move the whole line this way. And as I move it this way, it's moving down further and further on the fixed demand curve. But think of another black dowel here as the demand curve. So I've got the supply curve here, and I've got a hold of the demand curve here, and I'm going to increase them both by the same amount, which means that I'm going to hold them here, and I'm going to be able to move them like this. As I move them like this, notice that the supply curve, I'll put it in red again. If I could measure it, it'd be nice. I'll measure it. There. there, and there. So the supply curve, no, they got to be parallel. If they're going to move the same amount, they got to be parallel, or pretty close to parallel, something like that. Okay, there's the supply curve. That's S1. And now we're going to move the demand curve by the same amount. So I need my black marker, and I need my measuring tool again. So we're going to move it, we're going to increase it by the same amount, which means I got to move this guy this far, this guy this far, this guy right here this far, this guy by the same amount, because I have these arrows the same. I say I'm moving them the same amount. And so what happens, I got to draw my D2 in here. It goes something like that. Okay? That'd be my D2. Now remember, we don't have a D1 anymore. We don't have an S anymore. But we do have our old point of where things were, and we need that for a benchmark. But let's erase S. And let's erase D, our original demand, and ask the question, well, where is the new equilibrium? Well, the new equilibrium is where supply and demand intersect. We're over here at point 2. Well, what can we say about what happened to the price? Well, it was right about here. Where is it now? Well, if they both moved at the same rate, we're going to be right where we were before, and price would not change at all. If they were both increasing at the same magnitude. Now, what about quantity, though? Well, quantity, Q2, quantity went up. So price didn't change, but quantity, we already have an X there. That's wonderful. This X goes over here, right here. But quantity went up. Ta-da. Ta-da. Now let's make it one. We could do the same thing. If they both went down by the same amount, then the price would stay the same, and then the quantity would go down rather than up. Think of the two dowels again as I move them back this way. The intersection is going to stay the same if I move my hands at the same rate. If I move one hand at a faster rate than the other, you can see the intersection is going to be different, in this case, lower. So if demand decreased faster than supply, then that's going to drive the price down while the quantity is decreasing. If supply is increasing, is that right? I got to get my dowels here. It's decreasing, decreasing, decreasing. Well, how can I do this? I don't know how to get around there to do that. It's relative. It's relative. If they're both moving at the same rate, it's going to stay the same. If supply is decreasing faster than demand, then it's going to drive the price up as supply decreases at a faster rate than demand decreases. And let's take it one more level of sophistication here. Let's go back and we'll just start over to have a clean slate here. So we don't have everything mucking it up. And for a dry erase board that's getting kind of dirty here, this is as close as we can get to being clean. But before we start, go all the way back to 0 here. What if we don't have a situation where we would know the magnitude of the change in demand versus the magnitude of change in supply? Let's just say that we know that supply is going down and demand is going up. So I won't even put an arrow there. I'll say down. It's shrinking. And demand is going up. It's increasing, but we don't know magnitudes. Well, we start out just like we did before. We start out with a demand curve, and then we have a supply curve. And we know that demand is going up. So demand is, well, we have to put our 1 here. P1, Q1. It's going up. So we don't know how much. It's going up a little or going up a lot. We don't know. We don't know. But what we do know is wherever it goes, I'll put, where's my red? Here's my red. Okay. We do know that when we go from D to D2, the tendency will be for the price to come up to a new level. and the quantity to go up to a new level. That will be the tendency of an increase in demand. But what about a decrease in supply? As supply decreases, we'll say right here, supply decreases, we're going to be moving from this point to our new equilibrium right there, P2. Now in this case, we don't know if the supply decreased to here, or here, or here, or here. Maybe it only decreased down to here. And you see where the supply crosses here, that will determine the quantity, the equilibrium quantity. Now the essential rule to know when we have simply changes without magnitudes is that we will know what happens to one of these two variables for sure. We don't always know which one we're going to know for sure. And the other variable we're saying not enough information to tell. So whenever we have a change up, down, 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 up, whatever combination we have, if we don't have magnitude, we will be able to tell for sure what's going to happen to quantity, but we don't know what's going to happen to price. Or we'll be able to know what happened to price, but we don't know what's going to happen to quantity. Now in this case, as we changed it based upon the supply curves and demand curves I drew, first quantity went up, and then quantity started going back down. But in either case, the price went up and the price went up. So we will know for sure that the price goes up, but we can't tell, we don't know what's going to happen to quantity for this given scenario, for that given scenario. Well, we could probably do another one of those, but I think you've got the message. Again, if you do not know magnitudes, we'll be able to know one for sure, but we won't know what's happening to the other one for sure. And in this case, we know for sure that the price is going up because it goes up and continues to go up regardless of whatever change of whatever magnitude that we have. I think we're going to stop there simply because I don't want to go too far on any one segment here so that we can go on to more things. And I don't really want to go more than 20 minutes, 15, 20 minutes. So I think we're probably about there, and we'll pick up in the next session.